Now start. This is process control trainer model Expo PCT PTF. In this trainer we can perform experiments in temperature control, pressure control loop, airflow control loop, ratio control loop, cascade control loop, on-off control loop, feed-forward control loop, and control valve characteristics. V2I converter and I2P converter also we can perform in this trainer. In this trainer, this is EMT8 instrumentation power supply cum multi-channel DPM panel. This is DPM is main useful for to display the pressure, flow, temperature. This is mains 230 volt AC. This is 3R mains. This is main power on, and this is for actuator panels. This is signal conditioner cum thyristor actuator panel. Lower part is signal conditioning circuit for control flow. It is common for all three panels. So bottom part is signal conditioning circuit for temperature, flow and pressure, and upper part is thyristor circuit to control the temperature. Input is 230 volt, output is 200 volt DC. This main top circuit is useful for temperature purpose to control the temperature. Bottom circuit is to signal condition circuit to see the what is the temperature, how much temperature, flow rate and pressure. This is EMT9, same panels, similar panels, another two panels. Here only you can see the signal condition circuit we use in second panel. Left side wide flow and right side pressure output. Here there is a one switch for temperature flow. So bottom side is flow, it is selecting flow, and if the switch is upper position, it indicates temperature. The third panel we are use extreme right side for temperature output. Here we are used for temperature, so the switch should be upper position. Here this is the temperature output. It goes to heater to control the voltage of the heater for the experiment of temperature. So input is 230 volt, output is 0 to 200 volt DC. This is computer interface panel. Here 4 ADC channels, 1 DAC channel, V2I block and pressure sensor. Here it is, you can connect the USB connector. You can connect USB you can connect the any laptop or PC through USB. Here it is process tank. In process tank Here you can control temperature and pressure. This temperature gauge, you can see the temperature, actual temperature in this gauge. And this is the pressure gauge. You can see the pressure of the chamber. This is I to P converter. Input I 4 to 20 milliampere. Output is 0 to 13 psi. This is AFR 1. So you can just set the AFR, should be 1.5 bar. These are two are AFR 2 and 3. This for the turbine flow and control flow. Control flow and wide flow. So you can set the flow of 4 bar. This our flow is control the flow in air flow, not water flow. These two are rotameter 1, rotameter 2. Rotameter 1 is control flow. This is rotamotor 0 to 30 LPM. For the air, it's a mechanical rotameter. You can see the flow of air. Here it is turbine flow sensor. You can the flow sensor is in turbine type. So this is control flow. So it goes through control valve. It's a control valve. This is the control valve. It operates 4 to 20 milliampere air to close control valve. This is another rotameter. This rotameter is for the wide flow. So these two rotameters are needed in ratio control. To check the ratio controls, so we want one is reference, another is control flow. This is control valve. Control valve goes to control the temperature chamber and pressure also it can control. After open the box, connect compressor back side of the air filter. We are going to make experiment, sample experiment, proportional integration, derivation, control in pressure loop. Connect the wiring sequence as per page number 4-11. Connect pressure output of the signal conditioning EMT 9 to CIP channel 0. CIP 6 to 9. This is V2I converter. Connect CIP 10 to I to P converter. CIP 10 I2P converter positive. Negative of the IP2 CIP 20. Pressure output 16 BPM positive. BPM negative, any of the negative. Connect pressure range. Connect this channel, first channel, sorry, second channel. Connect computer interface card. To USB. Here you can select PID 10.9 software. Set PB35, TI 10 second, TD 0.15, sampling time 0.1, KD always 10. Then go to setting, channel 1, channel 0 is your measure value, and set point from source panel.
सेट
सेट है ना ये कैसा है I2C
ये वो बराबर है ऑटोमेटिक होता है
I2C DAC1 and select USB I2C1 DAC, then OK, then auto start,
40-60 का जो भी जरा 40-60 आप बोलो अभी चेंज टेक पॉइंट 40% और उसके बाद में 60%.
Here we are giving 40% from 50% set value. Measured variable is following your set point. If you change the set point, you can change the set point. Here once again we are bringing 60% set value. So measured value is following your desired set value. Here it is display also showing same pressure, whatever you are giving measured value. So we are giving measured value 2 bar of the 60%, 1.2 bar. Here it is showing 1.10. Here, this is mechanical pressure, this electronic reading, mechanical reading, and this is computer reading. Of the air pressure of the chamber. So you can perform the experiment, temperature, airflow ratio, cascade also. So for example, this is airflow control. Similarly, you can perform the experiment, same block diagram, wiring sequence, and PID parameters. This is the graph you can achieve in the airflow. Airflow is also set point and your measured value. This is a closed loop control with airflow control system. You can perform experiment ratio control also. Same block diagram, wiring sequence, figure, and graph. The ratio control, one is your set point and the other is the ratio of the set point. Similarly, we can perform the closed loop control with temperature control system. Here block diagram, digital PID, same computer is digital PID control, and firing angle control. Firing angle controlled by this firing angle through power bridge, and it goes to process tank. Here the temperature is controlled of the heater through this power bridge, and sensor condition circuit. This sensor condition circuit is the temperature. It goes to channel 1. Same wiring sequence. You can set the values as per manual, and you can see the temperature. This is black is your set point of the temperature. The other is measured value. Always temperature is very slow process, so it will take much time to settle the process. Here in closed loop control temperature system also we can perform PI action, P plus I plus D action. This sub tank, so it is useful for to control the temperature, and inside chamber water you can control the temperature to cool down the temperature. So we can use this sump tank and water, this one.
हो गया.